All right, today we're cracking open one of the true workhorses of the modern world. We're going to answer a pretty simple question, but the answer is fascinating. How does a diesel generator actually make electricity?
You've definitely seen these things, right? Humming away at a construction site, maybe at an outdoor concert, basically anywhere you need power where the grid can't reach. But what's really going on inside that box? Well, it's this incredible process of energy conversion, and we're about to unpack it.
So, how does it really happen? I mean, think about it. How do you take a tank of liquid fuel and turn it into the electricity that can light up an entire room? It seems kind of like magic, but it's not. Let's break it down.
Okay, before we dive into all the diesel power details, let's take one step back and ask a really basic question. Fundamentally, what is a generator?
Now, this is the key thing you've got to remember. A generator doesn't just create energy out of thin air. That's impossible, right? It's an electromechanical device, which is just a fancy way of saying it converts energy from one form to another. It takes mechanical energy, think motion, think spinning, and turns it into electrical energy. So, the very first challenge is, where do we get that motion?
And that's where the heart of this whole machine comes in, the engine.
So, the engine has one job, and one job only: create motion. That's it. It's a lot like the engine in your car, really. It burns fuel, diesel in this case, which creates these powerful, controlled explosions. Those explosions push pistons, and that motion ultimately spins a crankshaft. It's just a big, powerful motion machine. Super important to remember. It's not making any electricity yet. It's just making stuff spin really, really fast. But hold on a second. How do you get a massive engine like this spinning in the first place? You can't just push it. It needs a kickstart, a little jolt of energy to get things going. And that is where this small but absolutely vital component comes in, this self-starter. It's basically a little electric motor hooked up to a battery, and its whole purpose is to give that first big push to the crankshaft, just enough to get the whole combustion cycle started. Okay, so the engine is running. But an engine this powerful can't just work by itself. I mean, it's generating a ton of heat, and it's super sensitive to any kind of dirt or gunk. So, to keep it running safely and efficiently, it needs a whole support crew. And first up in that support crew, we've got the unsung heroes of the whole operation, the filters. You see, any little bit of contamination can be completely disastrous for an engine like this, so it needs constant protection. And we're talking about comprehensive protection here. You've got an air filter, because you need clean air for the combustion to work properly. Then there's a fuel filter, to make sure no dirt gets in with the diesel. And finally, you have a lube oil filter, to keep the lubricating oil squeaky clean. That's what reduces friction and keeps all those moving parts from grinding themselves to dust. All right, next big problem for our support crew to solve: heat. And a lot of it. Remember, internal combustion is just a series of controlled explosions happening over and over and over. That creates an insane amount of heat. To stop the engine from, melting, it has its own dedicated cooling system. And you'll probably recognize this part: the radiator. The way this works is actually beautifully simple, but super effective. So you've got this hot coolant flowing from the super hot engine into the radiator's little tubes. The heat then moves from the liquid into these metal fins. Then a huge fan blows air across all those fins, which literally pulls the heat right out and sends it into the air. Then now, much cooler liquid flows back to the engine to pick up more heat, and the whole cycle just keeps repeating. It's this perfect, continuous loop that keeps the engine from getting dangerously hot. Okay, let's recap where we are. Our engine is running smoothly. It's protected by filters. It's being kept cool by the radiator. It is creating a ton of powerful, stable spinning motion. So, now what? Now it's finally time to make some electricity. This, my friends, is where the real magic happens. It all goes down inside a component called the alternator. So the alternator is basically made of two really important parts. You've got the stator, which is the stationary part on the outside. Just think of it like a big hollow cylinder lined with tons and tons of coiled copper wire. Then you've got the rotor. This is the part that's connected to the engine's spinning shaft, and it rotates inside that stator. So the key concept here, the whole idea, is that you have a spinning part inside a stationary part. That relationship is everything. So how does spinning one thing inside another actually create electricity? Well, it all comes down to this fundamental law of physics that pretty much powers our entire world. It's called Faraday's law of electromagnetic induction. Sounds complicated, but the idea is actually pretty straightforward. We turn that spinning rotor into a powerful electromagnet. Then, as the engine spins that magnet like crazy past all those copper wires in the stator, that moving magnetic field gets the little electrons in the wire all excited and makes them start moving. And what is a flow of electrons? It's an electrical current. That's it. That's the moment. Motion is officially converted into electricity.
And just like that, we have power. We're making electricity. But you can't just have a generator running wild. That would be super dangerous and pretty useless, right? We need a way to manage it, to monitor it, and to protect the whole system from damaging itself. In other words, we need the brains of the operation. And this right here is it, the control panel. You can think of it as the command center for the entire generator. It's what lets an operator safely start it, stop it, and just keep an eye on everything that's happening inside. So this control panel really has three main jobs. The first one is simple: operate. You know, your basic start and stop buttons. The second job is to protect. This thing is constantly watching for any problems, like if the oil pressure gets too low or the engine temperature gets too high, and if it spots trouble, it'll automatically shut the whole generator down before any real damage happens. And its third job is to let you observe. It displays all the important data, like voltage, current, and frequency, so the operator knows for sure that everything is working exactly the way it's supposed to. So let's just quickly recap that entire incredible journey of energy. It all starts out as chemical energy, just locked away inside the diesel fuel. The engine comes along and converts that chemical energy into spinning, rotating mechanical energy. And then finally, the alternator uses the magic of electromagnetism to transform that motion into the electrical energy that powers our world, from chemical to mechanical to electrical.
It's just such a powerful series of transformations, isn't it? Taking a simple liquid fuel and turning it into something that can literally light up a city. And it really makes you wonder, doesn't it? What other everyday machines that we see all the time that we totally take for granted are hiding these kinds of incredible transformations right under our noses?